How you doing? I hope everybody is awake. It's too early for engineers. I'm Santosh Balasubramanian. I am a program manager in the Azure Stream Analytics team. And today I'm going to talk to you about more of real-time streaming. How do I take decision? How do I get insights from data in motion? The things that I'll cover today is, first of all, what is data in motion? What is this real-time insights that we are talking about? Customer scenarios and patterns. We have some customers from NEC who are going to come up on stage and talk to us about what they are doing with our system, and then actually deep dive into this real-time analytics. So, show of hands, how many people are dealing or have dealt with streaming data? Okay, that's good. What I will do is I'll give a quick example of what is streaming data. I always like to show this slide. Imagine you're in a parking lot, right? And somebody asks you the question, how many red cars are in this parking lot? Traditionally, I can run a query, select count star from parking lot where car color equals red. This query runs, counts the number of red cars, gives you an answer. But let's flip this question in a different way. Let's say you are in a freeway and you're at a particular point on a freeway, and somebody asks you the question, how many red cars have passed this particular point on the freeway in, let's say, in the last 1 hour? You could do this. If you want to do the previous way, you could either say, all right, I'm going to park every car which is passing this point, and then I'll ask that same question. Or I could do what we call real-time analytics, where I can run a query which is continuously running on this data in motion, which is this cars in motion, and it basically counts the number of cars which have passed this point in an hour, gives a result in the hour, and this query never dies, because every hour it is actually doing this aggregation, this count, and giving a result. That is what fundamentally we are going to talk about today. When we talk of streaming data, we're talking about sensors, which is actually sending data all the time. We're going to talk about applications, which is sending data all the time. So let me get started. Any guesses what this could be? Would you believe if I say this is Seattle PD's new breathalyzer? Let's see. It actually is not. This is actually a healthcare device. So I am going to open up a particular page. And I apologize, today in my session, I'll have to swap a little bit between slides and duplicating my screen. If anybody gives me a better idea in the end of the session, I would love to get that. So let's see. So what you're seeing right now is this is actually a device which is created by a company called Aerocrine. I'll talk about this company a little later. These were the first customers who went production on us. What they do is they help monitor asthma patients remotely. So this is the device which asthma patients, actually this is there in the Microsoft clinic as well, but other clinics which is there. But asthma patients could basically use this, and there is an app which is associated with this, which is there on my laptop, but I'm more showing this. Because when I actually breathe in and breathe out, and this app says what levels you need to be in, what is happening is, imagine if a doctor can remotely actually monitor the screen, correct? So now you can actually do things like remote monitoring. Other things that you see on the screen are things like the humidity and temperature. The Aerocrine is fundamentally changing their business, not just selling devices, not just connecting doctors remotely to their patients, but they are also adding a service on top of selling these devices, which is, I will help you monitor this. Technically, these devices are very, very expensive. So they actually see what is the humidity, temperature, and they give alerts to people who are having these devices in order to help them say that, hey, your temperature has increased too much, do something with it, right? So let me actually go back, because this is interesting. This is actually a sample set of devices, and this is their worldwide. Actually, this is a European company. I took one of the devices. This particular one was in Seattle, so I brought it. But you can see that there is a bunch of them which is there in other parts of Europe and other devices which are actually being used right now. So this is exactly what we are talking about. By the way, when I used this sensor, what happened was the data from this device went to the cloud, got some processing which was done on top of it, showed up on the dashboard, and I'm not showing you the alerting part, but there were also alerts which could have been fired in case things change. All of this is happening in real time with sensors like this. So let me actually jump back to the slides, and I am going to present. The name of this company is Aerocrine, and we have some case studies which is there, which has been done with Aerocrine. So it's similar to Aerocrine. We have a bunch of other customers, and the first thing which I wanted to talk to you about is what are customers wanting to do? What are these Aerocrines of the world wanting to do? So we have customers who are doing things like real-time fraud detection. So fraud detection can be done in multiple ways. There are threshold-based fraud detections, which I will talk about, as well as machine learning-based fraud detection. Hopefully, if time permits, I will today show you some of the things that we are going to do in the future. And we are actually getting in private preview of how do I do real-time scoring of machine learning models with streaming data. We have customers. We have a customer out of Europe who is having a connected car scenario. So what they're saying is, I have cars which have sensors in them, and these cars actually monitor things such as, is there slippage on the road? What is the condition of things which is happening within the car? And they are able to detect the fact that, let's say there is an icy condition on the road. So once they detect there is an icy condition on the road, most of these cars are actually connected using 3G, 4G networks. So once I detect that, I want to wait for the next 30 seconds. And if I see 3 or more cars in that same road which are giving me that same alert, I want to start taking some action. So I detect some sensor reading, I find some pattern, and I want to take an action. So these are the actions they want to take. I want to go to a map and say there is an icy condition on the road here. I want to be able to update other cars coming on the road saying, beware, there is something actually going on the road. I want to go and do proactive maintenance where I can call a cleaning crew and go clean up that road right now because it's a dangerous situation. There are customers that we are working with in the smart grid scenario. This is actually getting more and more interesting, and I'm sure all of you guys have heard about this. All of the intelligent smart meters which are there in your houses right now or in other places, they want to be able to collect this data in real time and do some interesting things with this. For example, I learned recently, and I did not know about the energy market, but the energy market is like a stock market. When you're reaching a situation when you need to buy energy, actually energy companies bid for this additional energy. So they want to make sure that I can actually optimize for my customers before I start bidding for this additional energy. What if in real time I could find out that these particular houses are over the particular average temperature setting in the house? So I want to send an alert to the customer, a text message to the customer saying, hey, decrease your temperature by 2 degrees and you will save $10 on your bill. Or they want to say, what is the most optimal time for you to turn on your dishwasher or other things based on what is the aggregate information, real-time information that I'm collecting from all other houses. So things like this are happening in the smart grid scenario. One thing which I will say, actually, if you go to the Microsoft IoT booth, which is there in the expo hall, you will see a company called Candy Controls. Candy Controls has been working with us. They work with Monterey Water. And they are showing how I can optimize for when should I use my solar power versus other sources of energy. Please go there. They will actually show you exactly what they have built on our system. We also have companies who are talking to us about real-time portfolio alerts. So the reason I'm showing you this is because when we talk of real-time, it goes across the board. We have somebody, a big company, which is trying to say things like, I want to do real-time pricing on my web page based on the number of people who are actually buying a particular product. So rather than doing batch analysis, I want to say if the average or the total count of people is greater than a particular threshold, then I want to increase the price. So things like this can be done in real time. What I thought is, just as I talked about healthcare, we have customers. NEC is one of our customers. And just like healthcare, they're changing the game. NEC is actually changing the game in retail right now. What they are doing is they want to be able to give real-time demographics information for people in a store. How do I connect physical devices with analytics so your customers and the store managers can actually make more intelligent decisions on how do I do promotions. So with this, I would love to call Imai-san to the stage, and please tell about what NEC is doing with us.
Okay, thank you very much. Good morning. My name is Hideki Imai, and from NEC Corporation. So we're going to talk about today's, just a unique IoT, solutions or activities what we are doing here. And you look at the face recognitions. We have unique video recognition technologies, and we're thinking about the IoTs. Earlier presented. The IoT itself is like a sensor and the devices connected and gather information in big data analytics. But we are thinking about the same way. But we have a unique solution and technologies to talk about the face recognitions. So we're going to introduce today what we are trying to do right now and different view of retail industries. And we are trying to change the retail industry's history of the doing the marketing and the promotion way to do. So just look at this. First of all, just the concept. So any industry, same thing basically. But for retail, specialized traditional conventional data, which is like sales information or inventory information. So those data exist. But on top of those, using face recognitions, using cameras, Kinect camera, normal cameras, to identify people's face and age. Based on face, we can estimate the age and the gender. So those information is really become variables. And people at the store like to know. What used to be, those information is not exist. So some kind of guessing work to do the next promotions. But using these technologies to find out what kind of people is coming to the store and how behave within the store. So those things is a very unique information to go next step. So what we did is identify people's face and estimate the age and the gender to adding the existing ERP and the CRM information. And then combined with also like external information, which is like a weather or temperature or also like a social network information. So those all combine and using Power BI to analyze more visual information and what people behave or what time people come into the store. Could be each different store, many stores, different type of the information required. So those are additional information, and I think goes to next phase for the retail environment. So that's a concept, basically what we're thinking about. And we have demos. We have a booth. You can come visit later on, but booth number is 324, I think. So that's a demo we are doing. So look at this. So this is just a demo purpose. So it's showing is a people face in front of the cameras, and identify your face first. Then right after that is looking at your age and the genders. So this showing the age range, but actually in the system itself is identify your age, estimate your age. So not exactly your age, but people look at it. This is NEC's technologies, and using lots of face information, and NEC's machine learning technology to estimate your face and estimate your age and genders. So that's information, and immediately after information comes, and we are not sending actual image of your face. This is a private issue, so we are not going to use, we are converting to the metadata, which is all numbers. So not going to going back to your original face information, but all information is numbers. So going to those information, update Azure. We are doing is Azure IoT suite, which is like an event hub, and also Stream Analytics to store at Azure side and in real time, and update Power BI to create a dashboard. So this is our image of dashboard. So you can see we are creating, this is last month's event which we had, and how many people came. Left side is 5,000 people came to our booth, and people ratios. Typically event came mostly, most part of the men came. So like left side on top is female-male ratios, those showing. And another thing is average age. People came to the booth is, of course, younger to older people. That's showing average age. So and also that showing on the map. We are using Power Map to create the graphs. So those things is very unique. And think about the retail environment. There are many stores, and each place and each cities, and you can see using these technologies to show which each store has different people to come in visit, and maybe products to in a store could be different. So that's demo we are showing, and you can come stop by later on our booth to see our technologies. So next step is, so how are we going to utilize this? So we have scenarios here. So people come into the store or any data signage tied with data signage. So people come into the place, and the system identify your age and genders, and of course store side is to promote some merchandise based on age and genders. So you can tie with data signage to display whatever promoted item or commercial things to display on data signage. And another thing is bottom side is people, as soon as people come into the entrance, you can identify face based on face and age and gender. So how many people come in and any time, date and time to see people, what type of people come into the store. And also, we have another technology to show pre-registered face, which is like a members. Once you registered with permissions, and people come in to identify who came to the store. This you can use like maybe hotels or airlines, and so as soon as you come in, the people identify yourself to automatically check in. No hassle to making line or anything. So that's those kind of technologies we can use, and this is a good example to go next step, I think.
Thank you very much. I thought this will be great. First of all, thank you very much to come from Japan. Please do visit the booth so you can actually see this in action. I thought this will be great to show exactly how a customer is connecting this physical world with the analytics that we are doing, and we can show you how you're doing real-time analytics in the system and fundamentally changing the retail game. So along with this, the next thing which I wanted to do, any of you guys attended Satya's keynote? So Satya's keynote, he probably talked about the smart lettuce thing which Fujitsu is doing. So this is yet another scenario that customers are working with us in order to do real-time analytics. So what Fujitsu is really doing is they are creating this lettuce for specific reasons. There are some specific health reasons, other reasons, that people want to have low potassium in this lettuce. Just so that you guys know, in order to create this lettuce with low potassium, there is a bunch of environmental issues that you need to actually work with, right? And this is monitored very, very, very stringently in their particular, in their plant factory. What they need to know, if the environment actually changes, I need to know about it immediately because I need to go fix that issue. So this, what Fujitsu is doing is they are using their sensors, which is getting real-time data, which comes into an analytics system, real-time analytics system, which is Stream Analytics, and I'll talk more about it, what it is, including they're actually even storing this data, doing machine learning on part of it, learning what are the patterns that I need to actually look at in order to make sure that my particular scenario or my particular production is not impacted. Once I learn about that pattern, I can operationalize that pattern on my incoming streaming data. Things like this is what customers are trying to do. So the last thing is I wanted to actually summarize some of these customer scenarios with canonical patterns. There are canonical patterns of, I get streaming data into the system, I want to archive this data. There's an interesting question which will be asked. Why do I need some kind of real-time analytics system in order to just archive all data? I'll give you an example. We are working with the botnet team at Microsoft, which brings in 700 million IP addresses per day, which is around 8,000 IP addresses per second. What they need to do is they need to take these IP addresses and they need to augment this with location information so I can actually show where are attacks coming from on a map. In order to do this previously, they used to store this IP addresses, then I think in Blob or SQL or someplace, then they used to have an offline batch process which used to run and get an IP mapping table which will actually take this IP to location, and then they could get it on a map. What they want to do is fundamentally change the game and say, in real time, every stream that is coming in, every event that is coming in, every IP which is coming in, I want to augment it with the location so I can show the data in a real-time map. I'll actually try to show you some real-time maps later today. Other scenarios, I want to strip PII. I want to do other things. So it's not just about storing this streaming data, but it's actually doing something with it before storing it. The next thing is dashboarding. And dashboarding, I wouldn't get a lot into it. We already saw some use cases of the dashboarding scenario, but I want to get real-time insights by looking at data in a dashboard. And the last thing is triggering workflows. And this is where most of the IoT scenarios actually fall into. It is not just about seeing the data. It is about what I was talking in the smart grid scenario. I want to take an action. I want to be able to notify customers whose thermostat is too high on how they can save money. I want to be able to notify when a particular situation occurs in my application. I will give you an example of this. We are working with an internal Microsoft team which is doing the monitoring of their application using our streaming solution. So this is what they're doing. They have millions of logs which is coming in every second. And what they want to do is they want to say, if I get a particular kind of an error, like 3 of these errors in 30 seconds in a particular time range, then I want to create a ticket out of it. I want to go wake up one of the engineers in order to go fix this issue immediately. The reason they are doing this is because in order to keep SLAs for service, you have 2 things, time to detection and time to mitigation. The faster you can detect, the more time you have to mitigate in order to keep it to your SLA. Other things that they are doing, a login process actually has 3 different events which occur in a sequence. So they are saying when a login happens, I want to make sure when the first event fires, do the other 2 fire in a row? If they don't fire in a row, then I want to wait for some time and make sure that this is happening in a pattern. Why this pattern is important is because people don't want to do things if there is a single anomalous situation. They want to see is there a pattern of situations before I can start making some things out of it. So before I move on, do people in this room resonate with what we have talked about from the customer scenarios point of view? Are these some things that you're interested in? Just a show of hands, like these are things. That is great. How many of you guys are interested in the IoT kind of scenarios? I'm curious. application monitoring. Great. So I will actually try to show some of these things. So with this, I'm going to jump into Azure Stream Analytics. So what is Azure Stream Analytics? Azure Stream Analytics is a fully managed stream processing solution. So the things that I have been saying, right? How many cars are passing this particular point on the freeway? You need a stream processing solution which has a query which is always running. It never dies. It always spits out a result. That is what stream processing is, and that's what Azure Stream Analytics provides. I will be the first person to tell you, we are not the first stream processing solution in the world, right? Stream processing has been going on. Financial companies have been doing this for the longest time. There are systems like Storm. Actually, Microsoft, my team actually owns another thing called Stream Insight that we gave out a few years back, and we are still continuing investments. But then why did we do this new service called Azure Stream Analytics? That's what I'm going to talk about today. Some of the challenges that customers have said with existing systems is things like, I need to get infrastructure. Streaming, I mean, you never know how much more data can come into the system. I will actually talk about a real-life scenario which happened last week in which you need to talk about scale. Doing stream processing is not very easy. Current systems, whether you talk about Storm or even our own system, Stream Insight, you have to write this logic in Java or SQL. Java or .NET. So think about writing some logic which is getting incoming streams of data, trying to find patterns in those streams of data, managing resiliency within the stream of data, because when you actually operationalize the system, you need to think about resiliency scale, and doing this multi-scale out. So all of these things are challenges which customers have told us. And what I'm hoping to tell you today is, as using Azure Stream Analytics, how you can go from event or data streams to your real-time insights, less people, less resources, and as fast as possible. Some of these solutions have been put up in a day. So, sorry, I'm not. Oh, I already talked about this slide. So let me actually jump into a demo. I try to do as many of my things through demos rather than slides. Okay. So now what I'm going to show you is this particular web page. Actually, I'm going to show you my kid because I haven't duplicated my screen. And he is actually looking at a streaming solution right now. I'm not kidding you. So what I have in my hand is this particular weather shield. This weather shield is getting live temperature, humidity, light, and all of that information from this room right now. This is connected to an Arduino Uno board and a Raspberry Pi device. This Raspberry Pi device is running Linux on it. And let's see if this is true. First of all, let me make sure it is coming. I am going to heat up my hand because you're seeing the temperature down there. Let's see if the temperature spikes. All right, this is really true right now. So the temperature is spiking right now. You saw that the light which is there has decreased. So what am I doing here? And let me walk you through the Azure stack and how you do real-time analytics on Azure through this particular live example. What I'm doing here is the data, the sensor data which is coming from this particular sensor is going to this Raspberry Pi. So this is actually being streamed continuously. From this Raspberry Pi, we are streaming the sensor data to a service called Event Hubs. Event Hubs is, think of that as a real-time ingester service. It's a, people familiar with the service bus service which is there? Okay, perfect. So Event Hub is a part of the service bus service. But think about connecting millions of your devices, not just this one Raspberry Pi, into this one Event Hub, which it actually scales up to 1 GB per second. So you can actually pump in a lot of data into the system. To tell you what is 1 GB per second, I talked about the IP address scenario, 8,000 events per second, which is coming into the system. That was 6 MB per second. So you can imagine how much data you can bring in. Event Hub also has things like retention policy on it. So this is basically the way to get your streaming data into the system. It has APIs. We have some code which is running on this Raspberry Pi, which takes the sensor data and pushes it into those APIs. So once the data comes into Event Hub, Now what? Now I want to do some analytics on it. I want to show it in the dashboard. Let me give you an example of the analytics. For this, I actually have sensors which is connected at other places at Microsoft and Seattle. So you see all of these sensors which are here. But what line I want you to focus on is this temp average. So there is this blue line which is actually showing the average. The average is here because there is one particular sensor which is very, very high. So how do I calculate this average? In order to do this, I will show you, I'll start walking through our Microsoft stack of services. So the first thing that I am doing is I am going to make sure I'm in this right Microsoft subscription. And I will show you event hubs really fast. So I am having an event hub here, which is a part of the service bus service. And I'm pushing all the data from this particular Raspberry Pi to this event hub called EH devices. After doing this, I want to do some processing on it. So I go down this list of Azure services, and I choose a service called Azure Stream Analytics. In Azure Stream Analytics, I can bring in this data from the event hub really easily. And the way I do it, people familiar with Storm, you have written some spouts for it. This is the way you actually write a spout. I just go, I click, so this job is running, so I cannot do it. But if this job was stopped, there is a button, Add New Source. I can add event hubs as a source or blobs as a source into this. I can add multiple sources of data or eventing data which is coming into the system. It's a click of a button and configuration. Then I want to write a query. So my query is, I am getting, let's say we are actually monitoring this whole convention center. So this has millions of sensors. And I want to get the average temperature across all the sensors in this convention center. Any guesses how many lines of code I might need to write for this particular query? And I want this query to be resilient. I want this to scale because this is millions of sensors. If there's a failure, I want it to recover. I want it to have checkpointing. All right, 20? Actually, anything can be written in one line of code. But jokes apart, this is all I need to write. This is really the only code that I need to write. And this is why I'm saying that we are making stream processing much easier and bringing it to the masses. And I will talk about how easy customers have actually set up end-to-end solutions. We have taken a SQL-like language and put it on top of stream processing. What we have underneath is something which is completely abstracted from the customers. But things that you want to do, I want to do aggregates. I want to find patterns. All of this can be actually done in a SQL-like language, and I will show you some of these things. But here, to do the average, I'm saying select average temperature from devices input. Devices input is basically the alias that I gave to my event hub. I could have multiple of these here. And group by a tumbling window of 20 seconds. So basically, I'm saying every 20 seconds, I want a result. Yes, there is a question.
You're using a syntax like time, etc.
Yeah.
It's streamed from the Linux device.
Yes.
How does the Linux device know which data to stream to the hub?
Okay.
And how is it interpreted?
So. Great. So the question is, how does the Linux data know what to stream to the hub, and how does the stream analytics solution actually get it? So what is happening is this Linux device has code running on it, which actually converts the sensor data into a JSON document. So it is sending things such as humidity and temperature in a fixed JSON document to event hubs. And in Azure Stream Analytics, we can read 3 formats currently: JSON, CSV, and Avro. So it can also be nested JSON, and I'll show you some examples. And that's how we do processing on top of it. Does that answer your question? All right. So some of the other things that I wanted to show you really fast before proceeding is, you see these 3 dots here, right? These 3 dots are actually alerts which are coming from the system, and there are other alerts which are also being fired. So for example, this alert is the light is over 80, the light is off. And I'm just sorry, this site is something with my computer. I have too many things running. But what I will show you is, how do I get that light is off alert? One thing, this light is off alert is coming when the light, there is less than a particular lumen of light coming which is 0.02 for 5 seconds, and at least one reading has come in. I'm from India. I know there's a lot of flickering, so I don't want to get this alert if there's a flicker. I want to give a condition. This is how I write the logic for it. I can actually say the light is off. It's a message. Any people familiar with SQL? Like literally, people who can know SQL can actually write this particular thing. Max time, this is when I want to get my alert. DSPL is the name of this device. That is what is actually being sent from here. And I'm getting this from stream input, which is actually exactly that same event hub. So I can write multiple pieces of logic on that one single event hub. I'm grouping this by a different window, which is a sliding window. And I'm basically saying if the average light is less than 0.02 and there's at least one count which has come in. This is how easy it is to do. I will show you a couple of others. Here is one other one which is coming into the system. So this one will basically say, I'm sorry, there's some connectivity issues. But if I wanted to say, like, if the average temperature is over 79 degrees, then again, you can imagine how I can write the same thing. I'm getting data, temperature over 79 degrees, and in a tumbling window of 20 seconds, where maximum temperature, which is calculated here, is over 79. So you can, once you can start thinking about this alerting, you can actually write it in a SQL-like language. All right. I can also do more complicated things, and I want to work into this. If the average humidity in the previous second is 20% greater than the average humidity in the previous 5 seconds, I can do things like that in the SQL language. I can do things like subqueries, think about it as temp tables, and I can take one stream of time and break it up into different chunks and join these chunks together. So actually, I'll show you a slide on this later. All right? So I will just summarize a little bit about, by the way, the code for getting data from, actually this whole setup is on GitHub, and the link is there for GitHub for getting this set up. We also have the link for how do I stream data from the band through a phone and things like that from this GitHub. All right? So I am going back to project. And I will walk through the next few slides very fast just because I want to summarize the system and I want to show you some more demos. Did this make sense to everybody? This, okay, perfect. So one thing is we are a fully managed real-time analytics service. Let there be no question. We are a CEP system, right? You can do everything like aggregating information. You can bring in millions of data together. I've given you some examples of that, and I will actually show you one live example of that as well. I can do very low latency processing in the system. So just like you can bring in up to 1 GB per second through Event Hub, we are actually going towards 1 GB per second processing that you can do in real time through our system. You can do things like finding patterns or lack of patterns, which is equally important. And you don't have to worry about hardware or software. The way you do this is you click a particular, just a button, that new button which was there on the Azure portal, and everything else is done for you. All you have to do is write your logic. You don't have to think of anything else except writing your logic in such a system. And we are available currently, I believe, in 10 data centers, and we are actually globally going to expand to every Azure data center. So you can actually expand your business globally very easily. The next thing is mission critical reliability and scale. We are guaranteeing event delivery. What we guarantee is if an event comes through Event Hub, we will not lose the event. Even if we have to restart the process, we can go back. I had told you about the retention policy in Event Hub. You can go back and read from those events and do your processing. So this makes sure that your business never loses data. We have built-in checkpointing in the system. What this means is if I have a 1-hour window when I'm doing something, and if I have a failure in the 57th minute, there are some systems which actually goes back to the 0th minute and have to read it, or your developer has to write code for checkpointing. This is built into the system. When a failure happens in the 57th minute, we actually recover very close to that. So it's as real-time as possible. You can actually audit things. So you can actually see when jobs were started, who are the people who started jobs, and things like that, which is actually built into the system, which is important for enterprise-grade scale. And scaling can be actually done on demand. So scale is very interesting. It's not just about scaling up. It's also about scaling down. When I was talking to some companies, financial firms, why are we building all this infrastructure for only when we have the market open. Interesting, connected cars. I didn't realize that the massive amount of data that they are getting, which is 90% of the data, is 4 hours a day, 2 hours in the morning and 2 hours in the evening. But imagine how they have to actually scale out and build that infrastructure. Using things like Azure Stream Analytics, I can scale up when I need it, scale down when I don't need it. I can use the efficiencies of the cloud for my business. And I'll actually show you an example of that as well. And of course, the last thing is rapid development with a SQL-like language. Do you mind if there's a few things? I'll keep some things for questions a little later. And this is where SQL-like language, when I go to my LinkedIn, I have at least 300 to 400% more people who understand, who have said that they know SQL compared to .NET and Java. And I used to be in MSR, so you can see what kind of a technical background people I know have. And then it has built-in temporal semantics. So this is where the example that I showed you, which was 5 lines of code, we did it in a competing platform, 1,400 lines of code for exactly the same thing. Why? Because it takes 1,000 lines of code to just build your temporal semantics. All of these things are built into the system as built-in functions. And the next very important thing is the more you go towards IoT solutions, and we are working with some big name customers. I cannot tell the name currently because we are still doing the case study with them. But here are things that will happen with IoT solutions. You'll have to start thinking about, I have data which is coming from a lot of my different places, right? Which have different gateways, that have different network latencies. But in order to find a pattern, I need to make sure that I can account for the network latencies between these different gateways which are sending the data. I need to reorder the events which are potentially coming from different gateways with different orders because of the time gap between them. These things has to be built in when you're starting to think about a real-time solution and production of these IoT solutions. In order to do what I just said, how do I account for network latencies? How do I account for how long do I have to wait? How do I reorder the events? All of this can be done with configurations in Azure Stream Analytics. You basically can actually say how long I want to wait. What do I do with events in case they arrive out of order? Do I actually change the time on the events or do I drop them? Things like this are essential when you're doing pattern detection and other things. And all of these are configurations. That's why I'm saying we're built for IoT-like services. So very fast, I wanted to show a canonical eventing scenario. So there are cases where data is coming from your applications, your devices. It comes through gateways, either field gateways which are there, devices like this, or even like from directly your sensors you're publishing into Event Hub. From Event Hub, if I want to do stream processing, I can use a service like Azure Stream Analytics, or if I might want to store the data directly. So Azure actually provides you ways of storing the data directly if you don't want to do processing on top of it. And then I can do a bunch of things on it. From Azure Stream Analytics, just like we can read data from Event Hubs or blobs, we can write data first party. In order to write data to SQL Azure DB, you don't have to write any code. All you do is what is your configuration you want to do. You can write data to blobs for your archiving or table store for archiving. You can actually do real-time dashboarding with the real-time Power BI aspects of it. So without writing a line of code, I can actually do dashboarding on top of my data. I'll actually show you an example of that. And once I store this, going back to storing the data, once I archive this data, I can follow patterns and practices such as I'm doing alerting or I'm doing real-time dashboarding on my data in motion. I'm storing this data. I can do HD Insight or machine learning to learn from this data and then operationalize it again on my data in motion. So these are patterns that people are doing, which can be done using Azure Stream Analytics. So I just want to quickly walk over exactly what NEC is doing here too, right? Just following this pattern. What they're doing is their cameras, which has the logic for this face gender detection, it is taking the data, it is passing it to Event Hubs. Through Stream Analytics, they are actually doing the calculations and manipulations, aggregations that they are doing on the stream, showing it in dashboards, or it can be in a store manager dashboard as well, a custom application, which gets data from their ERP and social systems. So you can see how NEC is actually implementing the same pattern. And if you want to learn more, you can talk to me. I can show you other patterns which customers are doing. The next thing which I wanted to jump into is, how many of you guys have heard about this thing called household.net? Did you guys know that I was one of the people who actually made it? So if you go to the blogs, you will actually see it is Quorum and me, our names were there in the blogs, and we actually built this pipeline, how to get the data. So let me actually show you really fast what is howold.net. This is also something which has got to do with face recognition, but it is completely different from what NEC is doing. What howold.net is basically doing is it's looking at the face APIs. There are some face APIs which have been released by Project Oxford in the machine learning team, and I'm actually a part of the machine learning team as well at Microsoft. So what it does is you can go to this web page, howold.net, you can click on use a photo, and it does things like gender detection. I apologize, I just realized that I did not duplicate my screen. So I will try another photo just to give you an example. I can search for Mona Lisa. And let's see if we use this photo, 23. I'm not sure if you guys know this, but when Da Vinci actually painted Mona Lisa, and based on who the character was supposed to be, she was 23 when he started the painting. He took years to complete it, but this is always a funny example I like to say. But this is just giving you some statistics about it. Let me show you something else. What you see here is a real-time dashboard of, I'll make this bigger just to show you the example, of people who are posting this data. I just want you to know this thing actually went viral. After Joseph, who's our corporate VP, released this on Build, it was the largest, it was the highest trending hashtag on Twitter. And you can see what we are actually showing here is it is not just about showing the fun experiment or showing how you can use the face APIs, but really doing web analytics on it. Really finding out things like what are the browsers, and I have cleared out this data. This is not the real data since when it was done. I just actually cleared it out, and I'm showing this, so please don't assume this is the usage. But this is real data of people who are using it since I cleared it out. But you can do things like what are the browsers people are using? How many pictures are some of the people who are actually uploading it in real time? What are the areas that people are uploading pictures from? Things like what is the average age and gender of things? And this particular line graph which is moving is saying in the last 10 seconds, how many faces of males versus females were actually posted into the system. Things like this can be actually done. I will tell you that what we wrote in the blog post, which is it took us 1 day from going and building this web page in order to building this pipeline. And I'll show you exactly why that got done. So when you do this web page, what happens in the back end is we are actually generating a JSON document, and you can click on view source here, and you see this JSON document. So this says what is the age, what is the gender, what is the latitude, longitude, IP address. There is absolutely no user information. There is absolutely no information about the photo which is done. It is just regular web analytics, like website analytics people who are doing. Anybody who's done this? Yeah, you would see like this is the normal things that you want to know, what browsers people are using. Once this is done, it is sent to an event hub. And from this event hub, we are using Stream Analytics and a bunch of different jobs on Stream Analytics. So one of the jobs that we are using is this job called age stats. So even though it is detecting age, what we showed you was we are showing you what is the age group that people are coming from. In order to do that, I'm sorry people are still playing around with this, but it's a very simple thing. All I do is I say face.age, if it is less than a particular thing, then I want to call it just a kid, correct? And that is what actually shows up in the dashboard. So if you look at the dashboard, it says just a kid. It is that easy to do it. I can set up any range I want. I can give it any name I want. And in order to create the dashboard, I read from Event Hub, this is the output I need to do. I just need to say that I want to create a data set in Power BI with these two names. And after that, I go to Power BI. I have a data set which is automatically created for me. And once this data set is created, I can go and create any of these graphs on top of it. It is that easy to do it. And that's why I said that in 1 day we were able to build this end-to-end pipeline. All I had to do was go and write this query. And then I will also show you another particular thing, which is the build age count aggregate. So this is basically a query that we wrote in order to say, in the last 10 seconds, what is the gender of people which have come into the system? What we are using here, I'm sorry, for some reason, my portal is slow from here. But what we are using here is system.timestamp, which is the timestamp of when I'm putting this data out. What is the gender? What is the count? And group by a hopping window of 10 seconds by gender. That's all I needed to do in order to create this particular line graph. So hope this makes sense of how we build this end-to-end pipeline in a day, and you can see of how fast you can build things in the system. I'm going to jump back and talk about scale for a second. When we released this, we didn't actually expect the scale that we got. Like literally, this was a spike the second that Joseph talked about this particular website, which happened in build. This spike is basically showing the number of faces which were uploaded. It was after a few hours, and you can just see how it kept on growing. And I can tell you that it has grown a lot. I can't give you the exact numbers because of obvious reasons, but I can tell you this has got more hits than a lot of things. It went viral quite a bit. Why I want to show you this is the importance of scale that I was talking, correct? In order to manage the scale, I did not need to do anything except say, I want to give more processing power on this. So let me actually talk about this processing power on this. What I am showing you a graph of is the amount of data which is actually coming through Event Hubs. So if you go to Event Hubs, you can look at the monitor page and you can see the data which is coming in. So each of this payload. At the max, this is in an hour window, so 14 million which came in on one of the days, right, in 1 hour. And that is 9 gigabytes of data which is coming into the system. The way I had to manage this is we have this concept of streaming units, and I will show you the page for that. All I needed to do was move the slider of those streaming units. And that's the way I can manage scale. When I noticed that things were kind of trending down, this is 2 streaming units, I just need to move that slider. We don't have auto scale right now, but that's what we are working towards. But why this is important is things which go viral, things like examples like this, need a platform, need a way that you can actually manage this. You can use our services on Azure in order to do this management of scale, virality, very, very easily. You don't have to change any code. You don't have to do any infrastructure to do this. By the way, at 9 gigs, 3 streaming units, if continuously I was having these 14 million per hour, for stream processing, I would need to pay $75 per month. And I will actually talk to you about the cost of what we are doing continuously for 9 gigs of this processing which is going on. So this is the SQL-like language I've talked about. You can see things like select statement, datetime functions, aggregation, temporal functions, string functions, windowing functions which are in the system. I can do partitioning as well. So these are auto partitioning which can be actually done in the system. Sorry, I've gone very fast. I have 20 minutes, but I'm hoping that this is the kind of content. Is this things that you're actually interested in? Does it make sense what I'm talking about? Perfect. I'll talk about a quick scenario and then I'll jump into another demo. This is the scenario I want to show you to just show you some concepts of windowing functions and other things which are there in our system. Imagine I have a Twitter stream which is coming into the system which has things like username, time zone, text, language, topic, and sentiment score. If I want to do things like filters, where I want to show the sentiment scores of people of a particular topic. I'm sorry, I should have realized I needed to change this particular thing. We had done this when Ebola was going on. But Xbox, Azure, if I want to say, I want all users, username and sentiment score with Azure, that's all I need to write. Then another very important thing in IoT is the timestamp. The timestamp can come from the timestamp when the sensor reading was taken, or the timestamp when the system or the event came into the system. Mostly 90% of the scenarios, the devices which are actually generating sensors, they have a timestamp associated with it, which is very important because that's how you can do pattern recognition, right? So in order to get the timestamps, and timestamps are important because the temporal nature of stream processing is very, very inherent. So you can do things such as timestamp by created at. If you do this, then what happens is I'm using the timestamp which is actually there in that payload or that event which is being generated from that previous example. If I don't do a timestamp by, then I use the timestamp of when the data automatically comes into the system. Scenarios where I don't care about the timestamp which was there on the device. So things like this can be automatically managed in the system. Windowing functions, we have 3 windowing functions. Tumbling window is basically, say if I want to say a 10-second window, every 10 seconds my query gives a result. It is doing the aggregations and different things. I'll go a little fast through this. Hopping window. So hopping window is basically what we used in the previous example, where I want results in a 10-second aggregate, but at the same time, I want this results to be spitted out somewhere in between that. So if I want results spitted out every 5 seconds, then I can say my window is 10 seconds, but I want a hop of 5 seconds. The other windowing function that we have is sliding window, and this is very commonly used for if something happens, then has something happened before it. So what this sliding window function is, every event when it fires, then you actually create a window, and I can say, in the last 10 seconds has something happened, or in the last 5 minutes has something happened from this event. So things like this I can do with sliding window functions. Then I can do things like joining multiple streams together. This is actually very, very important, because this is how I do pattern detection, right? So in this example, if I want to say, and imagine this is the Twitter stream which is actually coming into the system, and I want to say things such as, I want to find out a scenario where a person has actually changed his sentiment on the same topic and it's the same person. So complicated things like this, I can write in a very simple SQL-like language where I'm taking the Twitter stream. I can actually take that same Twitter stream and assume there are 2 streams which are coming into the system, and I'm doing a join, exactly like SQL joins, in order to find what is the username, what is the topic that I'm doing a join on, in what time range do I want to do this join, because you have to assume this is a streaming system, data is continuously coming, and what is my condition of the join. So assuming these are minutes, this will say that a person changed, XO changed his sentiment, but because this is more than a minute, this will not come in the result. So you can actually do things like this. I can do things like left outer joins in the system as well. Then we have a concept called reference data. So it's not always about streaming data which is coming into the system. So if I'm getting tweets into the system and I have a CRM system which actually has what is the handles of the user, I can join the streaming data with the reference data in order to do some logic on top of it, correct? Another example of this is exactly what I said for the IP address mapping. I have my IP address to location, which is a static data list in a particular place, and each row which is coming in, I want to augment the 2 of them together. So I can do things like this where streaming data and static data can meet each other using things like join in the system. So the next thing which I wanted to talk about, before I go into pricing, any questions? Sorry, I've been going a little fast. I just wanted to break down. Yes, please.
Do you have examples of position data, like geospatial functions?
The question is, do we have geospatial functions? Not currently, but this is something that we are working aggressively towards getting geospatial functions into the system. I can take one more question if it is there. Just a second before you raise the hands. Yeah. The question is, why am I using 2 devices, one Arduino and one Raspberry Pi? I could have, the reason I'm doing this is because to show the concept of a gateway. I could have actually had multiple Arduino devices connected to the same thing, to the USB. So I'll go into pricing and then I'll kind of jump back into more questions here. So how we price is based on 2 concepts. One is volume of data processed, and the other thing is streaming unit. A streaming unit is the amount of processing power that I am going to give a particular job. A job is basically the logic that I'm running on it, right? Running on the streaming data. So if I add these numbers together, oh shoot, I apologize. I should have done this in the very beginning. But if I add these numbers together, what you see is it comes up to around $25 per month if I'm running 1 megabyte per second processing continuously for a whole month. So 1 megabyte per second processing is 84 GB per day processing. So that is how cheap our solution is right now to get you into setting up your stream processing job. And that is why I said that even at 9 GB per hour processing, you can do your same system for $75. So this is a very important thing because this actually shows how I can start slow, I can manage scale, and I can scale up and scale down the system in order to do things. And I can almost assure you, I cannot even get takeout food for $25 a month these days, or a dinner these days. So before going to the machine learning part, what I have shown you until now are things which are there in production already. Something which I haven't told you about, and I will actually show it to you before I go into this particular aspect, is I can have multiple jobs which are actually, I can have a job which is running, which can do multiple stream processing logic. So here, while I was saying I want an alert when the temperature is over 79 degrees, I can have a single job which is doing this alert, as well as it's finding out logic for has the light been turned off or has the humidity increased, all of this in a particular job, because you're actually giving streaming units and processing logic to these jobs. Each streaming unit, and the way I actually do streaming unit and scale, is literally this particular page on Azure. I can go and increase my streaming units. We allow you to increase your streaming units to up to 1 GB per second processing that can happen. What we do right now is we throttle at 1 MB per second per streaming unit. So if your throughput, and this is why I wanted to show you that example of howold.net, I can see how much is my throughput coming in through the system. And based on that, I can actually change the amount of streaming units that I want. All right? So until now, I showed you everything which we are already in production. Now I'm going to show you something which we are working towards, and we are going to be in private preview. And how to sign up for the private preview, I'll talk about that later as well. So for this, any of you guys heard or used Azure Machine Learning? All right. So let me give you an example here to talk about machine learning. I showed you some examples where when the temperature is over 79 degrees, I want an alert. This does not always work. I'll tell you about a customer we're working with in London. They're doing some food truck delivery. And they're basically saying the problem with threshold-based alerts that we have is our trucks are in different environments. We can't always go and actually change the threshold for different environments that their trucks are in. So they want a system which can learn from the pattern of historic data and then predict an anomaly which happens from within that pattern. So this is where machine learning models actually come into the picture. This is where I can send my data to a machine learning model which will learn the pattern, and it can automatically detect an anomaly from that pattern. One of the case studies that we have done is with a customer called, or we are doing as a customer called SLAC, Stanford Linear Accelerator Laboratory. So they have the same problem. They have millions of sensors which is there in their laboratory. This laboratory does linear accelerator research, $1 million per day budget. So they have water coolers in which I have sensors which I need to monitor. In order to manage the system, which is a SCADA system right now, they spend hours and days and millions of dollars in order to just go and change these thresholds. So they want to use an automated anomaly detection model through which they can learn from the data which is coming into the system and automatically get alerts in case things happen. Another example, sentiment analytics. Because I was talking about Twitter sentiments. Everybody has heard this positive, negative, neutral sentiment. But I'm sure you would realize that all of these sentiments depends on the domains. I'll give you a very simple example. If you're working with a sports team, this is sick is actually a positive sentiment. It is not a negative sentiment, right? So what people are saying is sentiment analytics is great, but I cannot use the pre-canned models. I'll have to train a model for my domain, my specific use case. So that is what I'm going to actually show you as an example right now. So what I'm going to do is I'm going to go to Twitter, and this is actually going to go to the live APIs of Twitter and pull out some data about Howold robot. So this is the howold.net. Let's hope that people are tweeting about this. This is the 1% free APIs. But the interesting thing that I want to show you is the only data which comes into the system is some text created at, what are the user mentions. Oh, I am so sorry, I apologize. So what I did, let me just Control C this. What I did is I'm going to Twitter, and I am pulling using the free APIs of Twitter, the 1% rate limited, using my Twitter account, this hashtag called howoldrobot. So let's see, are people tweeting? So when I pull this data, what I had shown you is all that is coming through here is there is some text coming, some hashtags, language, this live Twitter data which is coming into the system. And I'm going to go back to the Power BI dashboard. I'm just going to refresh this, make sure things are working. What you see here is, however, this count which is increasing is of a sentiment. So you see here, as and when data is coming into the system for English language text, all of a sudden what I see is the sentiment score, positive, negative, neutral, how these sentiments are changing. Would you believe me that from here, what I'm doing here is I'm basically taking this data and pushing it to an event hub. That's all my small application does. From there to getting this live dashboard, it took one line of SQL. So let me show you what that one line of SQL is. I have to go to a different subscription because that's where I have put my this particular demo. What I'm doing is I'm calling a sentiment analytics model. It's actually a model very similar to this, which is the text analytics model, which is there in Azure Data Market. Later today, there will be a talk on this machine learning models, which is there in Azure Data Market and things like that. And I'm sending each of the tweets to this particular model. I'm getting it scored in real time. I'm getting that data back, and I'm pushing it to Power BI. In order to do that, I have a job which is running, which is called, I did this for build. So this job is called build Twitter sentiments. It is reading from this event hub. And this is the only query which is running for it. And as soon as this page actually loads, select text, sentiment of text. Sentiment is a user-defined function which calls the machine learning model with the text created at where language is English, and I want to output this to Power BI as a configuration. This is the only code I needed to write. What is the sentiment? Let me open this up really fast. What the sentiment is a user-defined function, and why I wanted to show you in this particular way is A, we haven't actually built our UX for this. B, I wanted to actually show you how I can get things like PowerShell scripts through which I can actually create jobs. So if you want to operationalize PowerShell scripts or APIs, you could do that as well. I'm basically saying this is the alias of the function. This is an endpoint, a machine learning endpoint. So when you take this machine learning model and you operationalize it, it gives you an endpoint. This is the key. So then I can use this exactly as a function, like I can do my adds, aggregates, and things like that. From here, and you will very soon probably see a tab here which says functions, and you can do those same things, which is all configuration, and then I just write this code. So hopefully this makes sense of how I am calling machine learning with real-time scoring data. Any questions on this before I proceed? Is this something which sounds interesting to you guys, actually real-time scoring of machine learning data? Because think of the aspects. I can use things like this for fraud detection. I can create my machine learning model. I can use things like this for demand forecasting. I can use things like this for things like anomaly detection that we are calling out. So if you're interested in this, very soon we're going to put out a blog, and we're going to give customers the ability to sign up with your scenario. And in this page, in this slide, you will also see the location for the blog from where you can sign up. So other things that we are working on things like hybrid stream processing, and this is basically for the IoT suite scenarios where I can run some part of my logic on devices like this and some part of my logic in the cloud. So how I can actually tie my SQL-like language running here with my SQL language, which is running in the cloud. So things like this are things that we are working on for IoT. My last thing, because now I have 5 minutes, I wouldn't be able to show it, is how many of you guys actually found this particular thing or real-time analytics interesting, the things in this session? Thank you for the show of hands. So now I'll give you a challenge. I have this another sensor in my hand. This is a Texas Instruments sensor. This also does things like live temperature, humidity, accelerometer, and a bunch of other things. What I'm going to do, I can't do it here because I don't have enough time, and this is why I was saying it's a 10-minute challenge. Please come down to the IoT booth or the expo hall where the Microsoft booths are. There's an IoT booth there. I'll be there. I will assure you that in 10 minutes, I will give you the sensor. If you want, it can be your Azure account or any Azure account, which is their My Azure account. And I'll show you how you can go from this sensor to a live dashboard or alerts which are showing in different applications. All of this can be set up in 10 minutes. In 10 minutes. If I don't do this in 10 minutes, I will buy you the free beer, or you have to buy me the free beer if I do it in 10 minutes. And of course, the time will increase based on how much beer that I drink. But that is where I'm talking about the simplicity of the system, right? This is what we will do. We will do dashboarding, and we will do alerting as well in different applications. And this is the complexity of the system. Data from this sensor, which comes through a gateway, which is there on your laptop, stream to Event Hub. Stream Analytics is running multiple logic on it, writing the data to another Event Hub, Azure SQL DB, Power BI, so I can have client application alerts, which I can see in MySQL or live dashboard. And I'm assuring you, I've done this before, that's why I can take this bet. So to summarize, first of all, I had made a statement earlier that stream processing, which is earlier seen as something which is very complicated, we have really tried to simplify that. Is it something that I've been able to show you guys and say how we have been trying to simplify the stream processing? Are people agreeing to this statement? Perfect, thank you. So that is what I want to summarize, saying it's a fully managed, low latency, high throughput stream processing CP solution. Things even like real-time scoring with machine learning is coming onto here. Things like hybrid is coming onto here. Enterprise level SLAs, built-in resiliency, scale, things that you don't have to worry about, and a high productivity with a SQL-like language, and built for IoT-like scenarios. These are the things that we are doing. All right, so I am going to leave you with some information with what are the resources that you can use. We have pages which talks about stream analytics. The code for this, your band, all of these things is actually going to be available through GitHub. You can go to the Azure Machine Learning Gallery, and you can actually do this 10-minute setup by yourself. Any questions? I only have 2 minutes, but I also have a bunch of my cards, which I'm going to keep out if people are interested. I'll take a few questions right now. Yes, sir.
Is it possible to have more than one output from a stream?
Yes. The question is it possible to have more than one output? Yes, you can. And actually, in that 10-minute challenge, I will show you how you can have multiple outputs. I can actually have different logics, which is going to different outputs as well. So I can archive my data as well as I can stream it live into a dashboard with Power BI, as well as I can actually get alerts in a particular application. Any other questions? Yes, sir.
What are all possible outputs?
The question is, what are all possible outputs? Currently, the possible outputs are Azure SQL DB, Table Store, Blobs, Power BI. We are adding things like service and event hubs, so I can output my data to event hubs so I can have other applications. We're adding things like Service Bus into the system. We are looking into things like DocDB as well. Yes, sir. So the question is it detecting when new blobs are added as inputs? Yes, so you can have blobs as inputs, and I will actually, if you come down later, I can actually walk you through how I can add blobs as inputs. Yes, sir.
Can you input lots of historical data into this as well? So like I have 5 years of old sensor data. Can I throw that in?
So the question is, can I input historic data into this? Yes, you can. What I can do, and actually we have somebody who was experimenting with this. What they did is put all the historic data in blobs, and then I can have blobs or event hubs as inputs. And they were basically saying, I want to start from this time of my historic data to this time of my historic data, and then I want to do some stream processing on it. Yes, sir.
Do the event hubs,
do the event hubs cross regions? What you could do is you could actually have data coming to different event hubs which are in different regions. And in my stream analytics job, I can add multiple event hubs as well. So, yes. So the question is, do we have auto-scaling? Not right now. We don't have auto-scaling, but we are working towards it. What you can do currently is, as I had shown you, you can look at your statistics. You even get alerts into the system where I can basically go and say, when I have reached the limits of my streaming units and I want to increase my streaming unit or decrease my streaming unit. Actually, that is one thing I can show you very, very fast. I have a dashboard, and in this dashboard, sorry, for some reason things are a little slow. I can go to what is called my operations logs. And in my operations logs, I can actually see logs of things. If I'm actually building the system, I can see logs of what is really happening behind, what are the failures which are happening behind. This is where I can go and do some of my processing. Hope that answers your question. Yes, sir.
Would it be possible to monitor whether data is flowing in from the sensors? For example, if I try to get a geolocation, I have to get 3 measuring points, and when one or more is failing, that is useless.
So the question is, is it possible? The question almost seems like if I'm getting data from 3 different points and one point is failing, then how do I find that it's failing in order to actually make sure I'm using the right points in order to do my processing? Yes, you can do that. What I can do is I'll use a left outer join kind of a function to say, am I getting data from all 3 points? If I'm not getting data from all 3 points, then I can add a case statement into my system to say what I need to do with it. So things like that can be done. All right. Hope this was useful, folks. Thank you very much. If you're interested, I have a bunch of my cards. Please feel free to take.